Hello students, have you ever wondered why some elements behave like close relatives, almost copying each other's chemistry? Just like in a family where members share common traits, the periodic table too has its families. These families are called groups, and in today's class we'll focus on four very special ones: the alkali metals, the alkaline earth metals, the halogens, and the noble gases. Each family is located in a fixed column of the periodic table and is recognized by its valence electrons. That's why their chemical properties are so strikingly similar. By the end of this session, you'll see how these groups form the backbone of chemical reactivity in nature. Let's begin with Group 1, the alkali metals. These are lithium, sodium, potassium, rubidium, cesium, and francium. They are soft, silvery white metals that can even be cut with a knife. What makes them special is their one valence electron. This single electron makes them univalent and extremely eager to react. In fact, they are some of the strongest reducing agents we know. Place sodium in water and you'll see a vigorous reaction. Two atoms of sodium solid react with two molecules of water liquid to produce two molecules of sodium hydroxide aqueous and hydrogen gas, written as 2Na plus 2H2O gives to NaOH plus H2. The reaction releases heat and often sets the hydrogen on fire. This is why alkali metals are stored under kerosene to prevent explosive accidents. Their reactivity grows as we go down the group, making francium the most reactive of them all. Next comes Group 2, the alkaline earth metals. These include beryllium, magnesium, calcium, strontium, barium, and radium. Each has two valence electrons in the outermost shell, making them divalent. Like the alkali metals, they are also reactive, but a little less so. They form oxides and hydroxides that are alkaline in nature. A good example is calcium oxide reacting with water to form calcium hydroxide, commonly known as slaked lime. This reaction is written as CaO solid plus H2O liquid gives CaOH to aqueous. If you've ever seen lime water turning milky when you blow into it, that's calcium hydroxide reacting with carbon dioxide to form calcium carbonate. These metals may be less reactive than Group 1, but they play an equally vital role in building materials, biological systems, and industry. Now let's turn to Group 17, the halogens. This family includes fluorine, chlorine, bromine, iodine, and astatine. Unlike groups 1 and 2, halogens are nonmetals with 7 valence electrons, which makes them just one step away from a full octet. That is why they are such strong oxidizing agents. They love to gain that last electron. For example, hydrogen gas plus chlorine gas gives hydrogen chloride gas, written as H2 plus Cl2 gives to HCl. These elements are highly reactive, electronegative, and dangerous in their pure form. Fluorine is the most reactive, while iodine is the least. They form salts when combined with metals, for example sodium chloride, our common table salt. This is why the word halogen literally means salt producer. What's fascinating is that within this single family, we can observe all three physical states at room temperature. Fluorine and chlorine exist as diatomic gases, bromine is a diatomic liquid, and iodine is a diatomic solid that sublimates to give beautiful violet vapors when heated. This gradual change from gas to liquid to solid as we move down the group reflects an increase in molecular mass and van der Waals forces. So, halogens don't just demonstrate chemical reactivity, but also showcase clear physical property trends across the periodic table. And finally, let's talk about Group 18, the noble gases. This group includes helium, neon, argon, krypton, xenon, and radon. These elements are truly unique because their outer shells are already full. Helium has a stable 2-electron configuration, while the rest have the classic octet. This makes them chemically inert, unreactive, and monoatomic. Their valency is zero. But being inert doesn't mean being useless, they have wide applications. Neon glows brightly in neon lights, helium fills balloons and airships because it's lighter than air and non flammable, while argon is used in welding as a protective gas. The stability of noble gases shows us the ultimate goal of atoms to achieve a completely filled outer shell. So, let's bring it all together. Group 1 alkali metals are soft, reactive, and form strong alkalis. Group 2 alkaline earth metals are divalent, less reactive, but equally significant. Group 17 halogens are powerful oxidizing nonmetals that form salts and covalent compounds, while Group 18 noble gases are stable, inert, and extremely useful in daily life and industry. These four families, the alkali metals, alkaline earth metals, halogens, and noble gases, highlight how periodic grouping explains and predicts chemical behavior. I hope this session helped you see these groups as living families of the periodic table, each with their own personality. In our next class, we'll continue to explore more periodic trends and patterns. Until then, keep observing the chemistry around you, it's everywhere.